Hello friends, this video just the extension of my previous video. In my previous video, I explained how to draw some important rays, some principal rays. That means by the help of a convex lens or concave lens, when light passes, how it behaves after passing. That means after refraction. So in this video, I am going to explain about the formation of images by a lens. So in this video, I shall take the help of my previous video where I explained how the light rays behaves after the refraction. Let us start. Formation of images by a lens. See here. Suppose now the object is between optic center and fast focus. So you see the convex lens. This is the principal axis. You think that the lens is very thin. So O is the optic center. Equal distance from the optic center, you mention here F1, first focus. Same thing in this side, we mention F2, second focus. Here at the equal distance, I can mention to F2. Here I can mention to F1. Object is between O and F1. For example, see, I am taking between O and F1. OB is the object. So from here I am taking one parallel ray. In previous video I said that the ray which comes parallel to the principal axis after incident, after refraction, passes to the focus. That means it will pass through F2. From this point, I have to take at least two incident rays to get the image. Already I have taken one, I am taking like this. That means I said the ray which incident at the optic center, it refract without deviating, whether it is the concave lens or convex lens. These two refracted rays, they are diverging, they won't meet. So if we produce them, then it seems that they are meeting. So this is the image. So which type of image? What is the characteristics of the image? First, image at the same side of object. Which side object? Image is also same side. Second thing is that it is virtual. This is erect and magnified. So this is the image formation by a convex lens. So this is the convex lens. I am explaining the image formation in a convex lens at different positions. After that, in concave lens also I will take. So this is about the way how the image formed by a concave lens when the object is between optic center and focus. Okay. So this is just like the image formation in a concave mirror, what I explained in reflection of light. Let us see the second case. Second case, object at f1. So this is the lens, principal axis, plane of the lens, optic center, f1 to f1, f2 to f2. Now I am taking the object at f1. Object at f1. So the ray which comes parallel passing through the focus. Okay. Next, from this point, the incident ray meet at the optic center. So it moves undeviated. That means these two rays won't meet. There will be no image. Since they are not meeting, these are the parallel rays. We can consider that image at infinity. Image at infinity. If it is at infinity, that means definitely it is real. Every real image is inverted. Since it will meet at infinity, nobody has seen the infinity. Okay, so inverted, I can say that it is highly magnified because it will meet at infinity. This is about the characteristics of the image formed when the object at f1 in case of a convex lens. Okay. Now let us see the another case when the object is between f1 and 2f1. Object between f1 and 2f1. Object between f1 and 2f1. So this is the lens, principal axis, plane of the lens, optic center. So this point is f1, this is 2f1, this is f2, this is 2f2. So now object at f1, between f1 and 2f1. Suppose the object is here. Okay. This is the incident ray which is moving parallel to the principal axis. So definitely it will passes through this focus. Next one. Okay. In this case, the incident at O. So it moves like that only. Okay. So it is meeting here. So the point, this point, suppose this is O, this is B. From the point B, I have taken two incident ray. So this point is the image of a B. I am writing B dash. From here, you have to draw the perpendicular to the principal axis. And this is O dash. Means O dash B dash is the image of OB. That means every point on O dash B dash is the image of a point correspond to the point on the object OB. So from OB, infinite number of rays are going, but it is not possible to draw all these rays. Only we are drawing two incident rays because we know that at least two rays we need which can meet and make the real image. If not meet appears like meeting, it makes the virtual image. That's why two rays I am taking. Those rays behavior already known to us. Okay, what I explained in my previous video. So here the image where formed? Image beyond 2f2 real, inverted and magnified. Real, inverted and magnified. See this one. Okay. So this is incident, refracted, this is incident, this is refracted. Let us see the next position of the object in a convex lens. Object at f1. At f1. So this is the lens, principal axis, f1 to f1, f2 to f2. This is the plane of the lens, okay, which divides the two convex surface. This is the optic center. These two are perpendicular. Now object at f1, object at 2f1, okay, already I've taken here object at 2f1. So draw a line which is perpendicular to principal axis. Now this is the incident ray, so this one is the refracted ray. Clear? Now what happening? Okay. This is the refracted ray. Okay. Now from here this ray, this is the incident ray. It incident at optic center. It passed through this optic center without changing the direction. So it is meeting here. From here you draw the perpendicular. From here you draw the perpendicular. Okay. Now where the image formate? Image at 2f2. Real, inverted, same size. What is the size of the object? Size of the image also same. Object at 2f1, image at 2f2. Okay, or you can say this is the c1, this is the c2. So object at 2f1. Next one, object beyond 2f1. Object beyond 2f1. This is the convex lens, principal axis, plane of the lens, optic center, f1, here to f1, equal distance from here to here, f2, this is the 2f2. So I have to take the object beyond 2f1. Suppose I am taking here. Okay. So it moves parallel. So after incident, it refract through the focus. Okay. Next one. See that it incident at the optic center, it refract without deviating. So where the image formate? Image between f2 and 2f2. f2 and 2f2. Real, inverted and diminished. Real, inverted and diminished. Next one. Object at infinity. So This is the convex lens, principal axis, plane of the lens, optic center, plane of the lens and principal axis both are perpendicular. So here is the f1 to f1, f2 to f2. Okay, object at infinity. So the light rays comes from far away, comes parallel. Okay, these two I have taken parallel. It may be parallel to the principal axis, may not, it does not matter. But those are coming far away, they are coming parallel. So you know that this parallel ray, it will refract through f2. Here also it will refract through f2. That means where the image formed? Image at f2. Real. They are meeting really. So the real inverted and highly diminished. Highly diminished means point size. Okay, that means the image formed at the focus. See that by taking this idea we can find the focal length or principal focus of an unknown convex lens approximately. How? Take a convex lens, means biconvex lens, show it towards the sun, and in front of it you take one paper. Adjust the distance between the lens and paper until getting a clear image of this sun, means one pointed image of the sun on the paper. You have to adjust it. One stage will come where the image of the sun will form on the paper very small in size and brightened. That means in that place, if you place the paper, after some time the paper starts burning because all the light rays, all the heat coming through that concentrating at that point. Like that way also we can find the approximate focal length of that convex lens, because the sun is at infinity. Light rays coming from the sun, it comes parallel. So this is about the formation of image by a biconvex lens and the characteristics of the images. Okay, now let us move towards the concave lens. So next one is the concave lens. So in concave lens, like the convex mirror, two cases will come. What are the two cases? One is object between optic center and infinity. Between optic center and infinity. Okay? See here. This is the biconcave lens, means concave lens. This is principal axis, this is the plane of the lens, this is the optic center. Here I am writing f2, here I am writing f1, this is 2f1, this is 2f2. Any places you can take. Okay? Suppose I am taking the object is here. Now light ray comes here, it is coming parallel. We know that which comes parallel, it refracts in such a manner. However, it is coming from f2. That means the refracted ray, if I produce backwards, it will meet at the f point f2. Next one. The ray incident optic center. So it will refract without changing the direction. Okay. So this is the meeting point where the image will be virtual image, because this ray is not the real. This is the virtual. Okay. So I can say that image between O and F2. Between O and F2, virtual, erect, and diminished. Clear? Next case. This is biconcave lens. This is the principal axis. This is the plane of the lens. Optic center. This is F2. This is 2F2. This is F1. This is 2F1. Suppose the object at infinity. Object at infinity. Now you see, if the object at infinity, the light rays comes parallel, and we know that those comes parallel, they refract in such a manner, however, coming from F2. So the image format at F2. So I can write the image at F2 virtual, erect, and highly diminished. Highly diminished means it is the point size image. Here the image format due to production of these two refracted rays backwards. So the image is purely virtual image. It cannot be formed on the screen. Only we can see it. We can observe it if our eyes are this side. If our eyes we place between these two refracted rays, then we can see. So this is about the formation of image by both convex lens and concave lens. Children, I hope that you will share this video with your friends. So until the next video, bye.